Exercise 12.3, linear functions, parallel and perpendicular lines. Point slope form and slope intercept form. The name of each of these two different types of forms will tell you which form you need to use. If you are given a slope and a y-intercept, then use slope-intercept form right away. If you're given a slope in any other point other than the y-intercept, then you are going to want to use point slope form. There is point slope form in this formula. M is equal to the slope. Our point x1, y1 is the other point that we would know in order to write the equation. Slope-intercept form, y equals mx plus b. M is still the slope, and now b is the y-intercept. We are going to begin with point slope form first and then convert to slope intercept form, unless you are given the slope and the y-intercept. Then you'll go right to slope intercept form. So for any line, regardless of the form, we have to know the slope. Slope is equal to m in both equations, which is the rise over the run. If we think about rise over run in the coordinate plane, here's the x-axis, here's the y-axis. If we start at the origin and rise, what axis are we moving along? We're moving along the y-axis. So that is always the difference in y's. Do not get mixed up. If we run in the x-axis, well, if I start here and I run, we run horizontally. That's along the x-axis. So it's always difference in y's over difference in x's. Identify the slope here between these 2 points. Slope, difference in y's, 22 minus 2, over difference in x's. Now, whatever order, since I went 22 minus 2, I have to go 8 minus 3. If you mess up the order and do the opposite order one time that you do the other, you're going to have the sign wrong every single time when you calculate slope. Slope then is 4. Find the slope of this line. Well, to find the slope of a line, we want to put it in slope-intercept form, which means we want to solve for y. So subtract the 6x over to the other side. Divide everything by 12. Simplify. Negative 6 over 12 is negative 1/2. 13 over 12 doesn't simplify. Slope now of this line is negative 1/2. Intercepts. An x-intercept is where the graph crosses the x-axis. If it is crossing the x-axis, and we think about the coordinate plane again, every single point on the x-axis here has the same y-coordinate. That y-coordinate is always 0, which is why an x-intercept will always have the form of x, wherever it's crossing, comma 0, which means also that we can plug 0 in for y and see what x is equal to anytime that we want to find an x-intercept. Likewise, a y-intercept is where the graph crosses the y-axis. If I think of a point along the y-axis, anywhere on the y-axis here, the x-coordinate is 0. So y-intercepts will always have the form 0, comma y, where we are plugging in 0 for x and see what y is equal to. Okay, find the x and y-intercept here for these two lines. Let's start with the x-intercept. To find an x-intercept, we plug in 0 for y. Divide. X is negative 3, which means our y-intercept is negative 3, 0. Y-intercept. We find a y-intercept by plugging in 0 for x. Solve. Now for y, divide. Y is negative 9/4, so our y-intercept is 0, negative 9/4. Letter B, y equals negative 2x plus 5. This time, this equation is given in slope-intercept form. So that means right away we know what the y-intercept is. Remember, y equals mx plus b. B is the y-intercept. In this case, the y-intercept is 0, 5. If you forget that, but you remember, well, I know if I'm finding a y-intercept, I plug in 0 for x. If we plug in 0 here for x, that's going to be gone, and y is equal to 5, so you can still get to it if you forget about slope-intercept form. X-intercept. To find an x-intercept, we plug in 0 for y. Solve this for x. Add the 2x over. Divide. X is 5/2, so our x-intercept is the ordered pair 5/2, 0. Write in equations in slope-intercept form. Slope-intercept form, remember, means that we want y all by itself. Letter A here is very close to point-slope form. 2 steps to go to slope-intercept form from point-slope form. Start by distributing the slope through. 1/2 times 4 is 2x. 1/2 times negative 6 is negative 3. Second step, always add the 4 over. Y equals 2x negative 3 plus 4 gives us 1. So y equals 2x plus 1. There is slope-intercept form. All right, here now, we do not have the slope. Regardless of the form we use, we know that we have to know slope for point-slope form or slope-intercept form. So let's do that first. Difference in y's over difference in x's. Negative 10 over negative 2. Our slope is 5. We now know slope, and we know a point. It does not matter which point we use. I'm going to use this second one, so I'm going to call that my x1 and y1 when we go to point slope form, because we know the slope and a point. Y minus y1 equals m times x minus x1. Plug in what you know. Y minus 6 equals slope, which we just found is 5, times x minus 4. Same 2 steps. Distribute the slope. Move the constant over. Y equals 5x minus 14. Parallel and perpendicular lines. Parallel lines, we know, are lines that never intersect. More importantly, what guarantees us that the lines never intersect is they must have the same slope. Remember, slope is the rate of change of a line. If they're both changing at the same rate, positive or negative, that means that they're never going to touch. Perpendicular lines. We know perpendicular lines do intersect. They intersect in a special way to form 4 right angles. And more importantly, what guarantees us that those lines are perpendicular is that they have opposite reciprocal slopes of one another. You must take the opposite and the reciprocal. It's not just the opposite or just the reciprocal. You have to do both when you're talking about the slope of perpendicular lines. Okay, so take this line and write the slope of the line parallel and perpendicular to it. Well, first, let's identify the slope of this line. The slope of this line is 3. So if the slope of that line is 3, that means any line that is going to be parallel to it has to have a slope of 3 as well. And any line that is going to be perpendicular to it is going to have a slope opposite and reciprocal, negative 1/3. Letter B, 2x plus 3y equals 6. First thing we need to do is find the slope of this line. So I want to solve for y. Subtract the 2x over. Divide everything by 3. We get negative 2/3 x plus 2. So we know this line has a slope of negative 2/3, which means any line parallel to that line has a slope of negative 2/3. Any line perpendicular to that line has a slope of positive 3/2. Last one. Write an equation of the line parallel and perpendicular to this given line, passing through that given point. So just like on the last slide, the first thing we need to do is recognize that the slope of this given line is 3, which means the slope of any line parallel is going to be 3, and the slope of any line perpendicular is going to be negative 1/3. So now we need to find these one at a time. Start with the line parallel. Line parallel to this line has to have that slope, has to pass through this point. So there's my x1, y1. Again, we know a point and a slope. Start with point slope form. Y minus y1 equals m times x minus x1. Plug in the point. Y minus 2 equals m, which is 3, times x minus a negative 6, which becomes x plus 6. Get to slope-intercept form, same 2 steps. Distribute the slope, 3x plus 18. Add the 2 over, y equals 3x plus 20. There's our line that is parallel to that given line passing through that point. We need to do the same thing now for the line that is perpendicular. Everything is going to be exactly the same, except we are now using this slope. So I'm looking at this line right here, y minus 2 equals, and I just need to change that slope. So everything else stays the same. It's still y minus 2, but now instead of a slope of 3, I'm going to have a slope of negative 1/3, and that's the only thing that changes in this equation. Distribute. Add the 2 over. The 2's cancel. We're just left with y equals negative 1/3 x.